And then this is the final question, question 8 from the Physics G mock final. The Oobleck galaxy is receding at 4,300 kilometers per second. And this is problem 8. And we know that a megaparsec is 1 times 10 to the 6th parsecs. We know that 1 parsec is 3.26 light years. That's key, right? We also know that there's the Hubble's law, which is V is HD, right? We also know that when the wavelength changes, it's change in wavelength over wavelength equals the velocity divided by the speed of light, only if this is less than, if this is much less than this, right? The second thing we got to be careful about is that this velocity here is actually in kilometers per second, right? A lot of people miss this, I think, on the quiz, right? And so when we get that one right, we've got to make sure that these are either both in meters per second or both in kilometers per second. I'm not sure right now which one I'm going to choose. We'll do whatever makes sense, right? So the first thing says, calculate the distance to this galaxy in light years using the Hubble constant of 71 kilometers per second per megaparsec, right? So V is HD, so 4,300 kilometers per second equals 71 kilometers per second per megaparsec times D, right? So D is going to be in megaparsecs. That's kind of a lot of parsecs, right? So we go 4,300 divided by 71. And I believe in the question that I give you, I have you calculate what the Hubble constant is. Given that it's a distance and a velocity, then you calculate h, and there it is, right? Remember, it's units. When you write it down, it's got units of kilometers per second per megaparsec. Okay? So it's a subtly different question, but it's the same exact formula, right? And so I do this, and I get 60.56 megaparsecs, right? And so what I'm going to do is I'm going to go 60.56 times 1e6, and that turns it into parsecs, right? Times 3.26, that's going to be light years, right? So this is megaparsecs to parsecs, parsecs to light years, right? So times 1e6 times 3.26, and that is a lot. My calculator gives me this very unhelpful number here, so I'm going to go second mode, scientific notation, enter, clear, second answer. I only have to do those 17 steps to get this stupid TI calculator to tell me what it is in scientific notation. Stupid piece of crap. 1.974 times 10 to the 8th light years. It's a nice piece of crap, though. It's a piece of crap that has a corner on the market. All right. There we have it. I could have written it down and counted the numbers, but I'm way too spacey. Okay. And then the next question says B. At what wavelength do we observe its 656 nanometers spectral line? And everybody got this wrong. It's going away from us, so the wavelength will be longer. Yeah? The wavelength is going to be longer because it's going away from us. So I'm going to use delta H. This is lambda, right? Is velocity over the speed of light, right? And when I get the change in wavelength, the wavelength is going to be the new wavelength is the old wavelength plus the change in wavelength. The wavelength is longer, okay? So let's just do this calculation. Delta lambda is to 656. As that velocity, 4,300 kilometers per second, is to, well, that's kilometers per second, so we got to use the speed of light in kilometers per second. So it's 3.00 E5 kilometers per second. The speed of light is 3.00 times 10 to the 8th meters per second. Is 3.00 times 10 to the 5th kilometers per second. Am I still on the camera? I think I am. Is that there? Yes. All right. Okay. So now I'm all set. I'm going to go 656 divided by 4,300 divided by 3e5. Enter. And I get... Okay, hold on. Let's go second entry. Definitely got the wrong answer. I forgot to times it. Okay, here we go. 656 times 4300 divided by 3e5. And I get that it's 9.4026. What is it? Well, if this was nanometers, then this guy's going to be nanometers, right? It's a straight proportion, right? So now my new wavelength is 656 plus 9.4026, right? So plus 656. And that gives me 665 nanometers. Yeah! So why do black holes have a stronger gravitational field if they didn't increase their gravity? What's the formula for gravity? For gravitational field, for force, right? It's GMM over R squared is the force, right? If the masses didn't change and G didn't change, what do you suppose changed about the black hole to make it bigger? Gravity field. Do you think it got small? You heard it here.